Welcome to the Explainer. Today we're doing something a little different. We're not just going to talk about network defense. We're going to put you in the driver's seat. Think of this as your first week on the job in a cybersecurity internship.
So, let's set the scene. You've made it through your first week at a big tech company. You've got your laptop, you know where the coffee machine is, and now it's time for your first real project. Your boss wants you to design a secure network from scratch. Ready? All right, here's our game plan. First, we're going to survey the digital battlefield. Then, we'll build up our defenses. After that, we'll learn how to divide and conquer the inside of our network. We'll touch on some cool automation, and then it's time for your big assignment. Let's do this. First things first, you can't defend a place you don't understand, right? So we have to start with the absolute foundation of how everything on the internet talks to each other, the TCP/IP stack. Okay, don't let the table scare you. Think of it like sending a package. The application layer, that's you writing a letter. The transport layer is basically putting it in a sturdy box, making sure it gets there in one piece. The network layer is where you write the address on the box. And the data link layer, that's the actual mail truck driving it down the road. As an intern, you've got to know that attackers can try to mess with any one of these steps. So, speaking of those addresses, we had a little problem. The old system, IPv4, literally ran out of addresses. I mean, completely. It's like a city running out of phone numbers. So we upgraded to IPv6. And yeah, it gives us a bajillion more addresses, but here's the real kicker for us. Security, specifically IPsec, is built right in. It's mandatory. That's a huge upgrade for baseline security. All right, so now we get how the roads work. It's time to start building some checkpoints and posting some guards. Let's talk about building up our network's defenses. Your number one first line of defense is always the firewall. I love this analogy. It's the bouncer at the front door of your network's club. It's got a very strict guest list, a bunch of rules, and if your name's not on the list, you are not getting in. Simple, powerful, and absolutely non-negotiable. But, what if someone's really sneaky and they slip past the bouncer? Well, that's what an intrusion detection system, or IDS, is for. This is like the security camera system inside the club. It's constantly watching for shady behavior, and if it sees something, bam, it sounds the alarm. Now we're going to take it one step further with an intrusion prevention system, or IPS. This isn't just a camera that sounds an alarm. No, this is the actual security guard who sees the problem and steps in to shut it down right then and there. It doesn't just tell you there's a problem, it actively stops it. So the IDS and IPS are the eyes and the reflexes of your network security. So you see how this all connects? It's this awesome feedback loop. The IDS detects something weird. That alert gets sent to a central brain, a system called a SIEM, to see if it's part of a bigger attack. Then the IPS steps in and blocks the threat. And finally, and this is super important, a real person, an analyst in the Security Operations Center, reviews what happened to make the whole system smarter for next time. It's a cycle that's always learning. Okay, our perimeter is looking pretty solid, but we have to assume the worst. What if a determined attacker still gets inside? Well, their first move is going to be to look around and see what they can find. Our job is to make that as hard as humanly possible. The strategy is called network segmentation, and it's a really powerful idea. Instead of having one big open floor plan office where anyone can wander anywhere, you create smaller, locked-down rooms. So the finance network can't talk to the guest Wi-Fi, and the guest Wi-Fi definitely can't talk to the critical web servers. And if you're thinking, does this really matter that much? Let me tell you about the target breach. This is the textbook example. The attackers didn't smash down the front door. They got in through the company that managed the heating and air conditioning. And from that one less secure spot, they moved sideways, laterally, into the payment systems. If there had been proper segmentation, it would have been like a locked steel door between the thermostat and the credit card data. Now, you're probably thinking, wow, managing all these separate zones and firewall rules sounds incredibly complicated. And you're not wrong, which brings us to a much more modern, much smarter way to manage this whole digital battlefield. So think of a traditional network like having a separate traffic cop at every single intersection in a city. It's chaotic. With software-defined networking, or SDN, you get rid of all those cops and replace them with one central traffic control center that sees the entire city at once. This central brain can make way smarter, faster, and more coordinated decisions for the whole network. And when you have that central brain, you can do some really incredible things.
For instance, if one laptop gets a virus, SDN can automatically kick it off the network and put it in quarantine, all in a fraction of a second. If you're getting hit with a massive denial of service attack, it can reroute all that junk traffic instantly. It's security that is fast, smart, and adaptive.
All right, intern, the briefing is complete. You've seen the terrain, you know the defenses, you've even got some advanced tools in your belt. Now, it's time to put it all together.
So here it is, your mission. You need to create the security blueprint for a totally modern company. We're talking cloud servers, we're talking sensitive internal data, we're talking public websites, and even a bunch of IoT devices like smart thermostats and security cameras. Your job is to make all of that stuff work together securely. A huge part of your design is going to be a firewall rule table that looks something like this. This is where the rubber meets the road. See Rule 1? That lets anyone on the internet see your public website. But Rule 2? That explicitly denies anyone on the internal network from directly touching the database. And Rule 3 stops your smart coffee machine from browsing the web. Every single line here is a conscious security choice. And the other side of the coin is being able to understand the data coming back from your systems. You'll see an alert report like this. You need to be able to look at this and go, okay, Alert 101, that's a high-severity SQL injection. Somebody's trying to hack our website. You have to know what these threats are so you know how to respond. So as you put the finishing touches on your design, I want to leave you with the one question that will honestly define your entire career. How do you find the perfect balance between locking everything down and actually letting people get their work done? Because look, the most secure computer in the world is one that's unplugged and locked in a vault. But it's also completely useless. Finding that balance, that's the real, never-ending mission. Good luck.